Hello data managers, this is the long-awaited least squares method lesson. In this lesson we're going to take a look at Unit 3, Activity 2, the simple linear regression and correlation analysis, and we're going to do the least squares method. So you'll remember that simple linear regression is where we try to find relationships between two variables. We can use them in a whole range of disciplines like business, economics, science, you name it. Now, in the least squares method, there are a few terms that I want to have you understand before we get started. Well, first of all, the goal. So we have a goal, and that is to determine the equation of a straight line that is going to best fit our data. That equation, the equation for that line, is called the regression equation or the least squares equation. And what we're going to do is we're going to create a graphical representation of the equation by drawing that line. So that line we call the regression line or the line of best fit. You'll hear those terms used interchangeably both by me and by a lot of other people. Now, why do we call it a line of best fit? Well, the reason is that the procedure minimizes the sum of the vertical deviations, and we call those deviations the residuals. You'll remember that from our previous lesson where you looked at the vertical lines. Now, we're going to take a look at the regression equation. So our regression equation is y sub p, so over here on the right hand side, y sub p equals ax plus b. You'll remember that as the equation of a line. Y equals mx plus b is the typical version of this. Y equals mx plus b. You'll notice we have y equals mx plus b. And instead of m, we're using a for our slope. So a is the slope of the regression line, b is the y-intercept, x is any single value of your independent variable, and y is a predicted variable of your dependent variable. Now here we have two nice fancy formulas for the regression equation to find both of the coefficients. We have our slope and our y-intercept. Now, when we use the least squares method, I suggest 5 steps. So, first of all, determine your dependent variable. Requires you to think a little bit, and that goes on the y-axis. Construct your scatter plot, and then you have to ask yourself the question, does your data have a linear relationship, or do you think it has one? Is it line-ish? I know that's not a word, but it sounds right. And then once you do that, you have to determine your regression equation and then plot your regression line. And once you plot your regression line, you can do a whole bunch of things with it. Now, for the least squares method, first of all, figure out your independent and dependent variables. So, let's take a look at the example from the content. The scenario we're given is many companies involved in assembly operations use aptitude tests on potential employees before hiring them, and also on current employees before promoting them. This is something that is often done in something like a car manufacturing plant, where you need to have certain skills, and you need to know that people possess those skills at a certain level before you can use them. Now, one thing that people want to do is to figure out how useful these particular tests are. So, in this scenario, Megatech Inc. has a personnel department, and what they've done is they've administered an aptitude test to a bunch of employees. So, 2 questions to ask. First of all, does the aptitude depend on the output? So, in other words, does the aptitude of a person to do something depend on the amount of stuff they produce? Or does the output of the person depend on their aptitude? So when you think about it, it makes a lot of sense that output depends on aptitude. It's going to be determined by the aptitude of a person. So we're going to say that aptitude is our independent variable and output is our dependent variable. So we've done step 1. We've determined our dependent and our independent variables. And now we are going to construct our scatter plot. So we're going to use Fathom to create our graph. First of all, let me show you how to use Fathom again. First of all, grab yourself a table, and in that table we're going to have to create a few attributes. So I've copied a picture of our data table from the content, employee, output, and test score. So those are our three attributes. And then the next thing is I'm going to start populating the attributes with cases. So employee A has an output of 31 and a test score of 5. And once you've created your data table, you will then add a graph to the picture, and we're just going to remove our copy of the data table. And you will create your graph using the two attributes. And remember that we determined that aptitude is our independent variable, and the output is our dependent. So here we have our scatter plot of aptitude versus output, and it looks very similar to the scatter plot that was provided to us in the content from the TI-83. So we've constructed our scatter plot. I've got a copy of it here in the slideshow. And now, third, we ask the question, does my data appear to have a linear relationship? Is it line-ish? And when we look at this graph, it very definitely does have a relationship. So then we're off onto the fourth step, which is determining the regression equation. Now, I've already shown you how to do it using technology. We're going to go back to first principles, and we're going to do it using basic algebra. So here we are at step 4. Remember our two coefficients. A is our slope, B is our y-intercept. So we have these two equations, and when you look at them, you'll notice that there are 4 items that we need to calculate, and that there's a 5th item that we already know. So n, which is the sample size, we know that's 6. And we also have to figure out the sum of x, the sum of y, the sum of xy, and the sum of x squared. If we do those 4 items, we have everything that we need. So let's take a look at our... So here's our table that we've used to compute all the sums. You'll notice here on the bottom right is our original data table. And you'll notice that the output with the second column and test score, the aptitude, is the third column. Now, when you think about it, we decided that aptitude was our independent variable, which makes it our x variable, and that output was our dependent variable, our y variable, and you'll notice that the values are in the corresponding columns. So do our computations, sum of all of the x's, sum all of the y's, sum of the product of xy, and sum of the square of x. We do all those things. We end up with 4 nice little numbers here. Actually, I guess they're a little bit bigger than little. And the number of objects in our sample, which happens to be 6. When we substitute our sums and our number of samples into the two equations, we end up with a coefficient a equals 2, b equals 20. So our slope is 2, and our y-intercept happens to be 20. And sub that into y equals ax plus b, and you get y equals 2x plus 20, which we can then use to graph our line. So I'm going to take you through the classic way of graphing a line. This is something that you've learned in grade 9, I'm sure. By now you can do it with computers very easily, technology, but I just want to repeat this just in case. So we need a minimum of 2 points to construct any line, and a third point is often recommended as a check to make sure that you made no mistakes. So what you can do is you can take 3 x values, substitute those x values into a regression equation, and then compute the y value. Plot those 3 values, and you should be able to draw a nice line through those, which in this case is a line of best fit. So let's take a look at the example provided to us. We take x equals 0, x equals 10, because those are 2 very nice numbers that fit nicely in our equation, and x equals 5 gives us the check. We compute all of those points with our x and y coordinate, plot our graph, and we end up with our line of best fit. So remember our regression equation, y equals 2x plus 20? Well, we're going to plot that. So y equals 2x, so 2 times, and we're going to use the aptitude attribute, since that's our x value, plus 20 gives us our equation of a line. We're going to plot it. So now here we have our line of best fit. Now, neat thing about Fathom is we can find the value of any point along a line just by clicking on the line. So some of the things that we're asked to do are dead simple here. So if you have a value of 4 for your aptitude, your output should be about 28 units. And you can do that for anywhere along this line. So if you have an aptitude of 8, give or take a few decimals, you should have an output of about 36. Now, let's use Fathom to do its own least squares line. So we're going to have Fathom create the least squares line. Here we have our line, our equation of the line. We've got output equals 2 times the aptitude plus 20. And you'll notice that it matches very nicely with y equals 2x plus 20. And in this case, our r squared is 0.83, which isn't too bad. And to remind you about the least squares nature of this, I'm actually going to show you the squares. So it's a neat way of showing the least squares concept, and that's how you eliminate the problem of having positives and negatives canceling each other out, because in theory every point above the line should have the same distance when you add them all up as all the points that are below the line. So by squaring it, you eliminate all the negative signs and you can get a least squares result that you can measure. You'll remember the cheat that I showed you in Fathom to find a y value for any given x value. Well, you also have to do it the old-fashioned way, substituting a chosen value of x into a regression equation and then computing the value for y. So in this case, x equals 6 will end up with a y equals of 32, x equals 10 gives you a y of 40, and if we look at our line, we should find the same thing. So a slope, or a value of 6 gives us a value of 32, and the other one was a value of an x value of 10 gives us a value of 40. So in a nutshell, that is using the least squares method to find the line of a regression equation. So once again, the 5 steps. First, we determine the dependent variable. Then we have to construct our scatter plot. Then we have to determine whether there is a linear relationship or not. And then fourth, we determine the regression equation if we determine that there is a linear relationship. And we finish off by plotting the regression line. So if you have questions, do make sure to reread the text that goes along with this content, and also do ask me questions. Mr. Dunbar signing off.